In this lesson, we'll be controlling a flow toolpath for 3 axes. After completing this lesson, you'll be able to create a multi-axis flow toolpath and modify toolpath parameters. For this lesson, we're going to carry on using our forming die part. We want to explore looking at multi-axis flow. When we take a look at multi-axis flow, this is a toolpath that by default is a 3-axis toolpath. So we're going to select multi-axis flow, and the first thing that we want to do is we want to select a tool that's appropriate. So I'm going to navigate to All, select Type and Filter by Ball End Mills. We're going to be taking a look at a 1/2-inch long ball end mill and saying OK. Then for our geometry section, I'm going to select a handful of these faces. I'm going to go all the way up into the center of the part and all the way down to the radius at the bottom. Notice when I select these that on screen it's showing me a bunch of red arrows. These are going to be the directions of cut. Let's go ahead and say OK and see what the toolpath looks like. You'll notice that the first thing that we get is just a single line on each of the surfaces. Now this is because a multi-axis flow toolpath in the passes section defaults to a number of stepovers set to 1. We're going to increase this to 10 and just take a look at the result. Once we set it to 10, you'll notice that now what we're doing is we're getting 10 different passes on each face. Now you might start to think about this as not being a very good option for this specific geometry in this specific part. And I would agree with you there, and what we would do in this case is come back and clear all of the geometry, and for example, just take a look at this fillet. What we want to do is in the passes section, we want to change the isometric direction to along V. Then we're going to say OK and allow it to calculate. So now what we get is a toolpath that goes around that fillet in that V direction, and we're able to control the number of passes in order to get the cut to look like we want. So if we go to simulate this, we can play through and you can see that this ball end mill is working its way around the fillet, creating that geometry in that cut. Now of course, based on the diameter of the tool that you're using, or whether it's a ball or a bull end mill, or maybe another spherical type of mill, you'd have to determine the exact step over that you would want based on the diameter and the radius of that tool. So from here, this is the basic application of using a multi-axis flow toolpath, but in a 3-axis manner. And we can go into the parameters and we can make additional adjustments. For example, we can increase the number of step overs to get a finer resolution. We can also change the direction so that it only cuts one way. We can modify the smoothing tolerance values, and we can change feed optimization. If we think that we're going to be in a situation where the tool is going to start to engage a lot of material, such as going into the corner of a pocket, we can use some of these options to help limit the load on the tool. From here, with the increase in the number of step overs, I'm going to go ahead and just say OK. And I want to simulate this, but I'm going to turn on my stock. When I simulate this with stock turned on, and we watch it make this cut, you can see that it's working its way around that fillet. And if we speed this up, you can see that 25 step overs leaves a pretty good resolution on this part with the 1/8-inch ball end mill. So this is a great toolpath that can be used for finishing things like fillets on parts. And this specific part is rounded, but even if it wasn't rounded, we could still use it in this 3-axis manner to get a nice finish on complex geometry. From here, let's navigate back to a home view and let's save this file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.